Hello, everybody. My name is Iya Chen. I'm a professor of phonetics at Leiden University in the Netherlands. It is my great pleasure to introduce our speaker, Professor Amalia Arvaniti, for today's Abraling ao Vivo Linguist Online. I'd like to propose that while I introduce this online forum and our speaker, you can all type in the chat some warm greetings, maybe in your own language, to Amalia and the audience. This is also where you're going to put in your questions and comments at the very end of the talk. For those of you who joined this forum for the first time, Linguist Online is an initiative of the Brazilian Linguistics Association and is designed to give students and researchers free access to state-of-the-art discussions on diverse topics related to the study of human language. We're very lucky to have Amalia Arvaniti here today. Amalia received her PhD from the University of Cambridge and has since held research and teaching appointments at a long list of universities, including the University of Oxford, the University of California at San Diego, and the University of Kent in UK. And we're very happy that she has moved to the Netherlands in 2020 and is now a professor of English at the Radboud University in Nijmegen. Amalia is one of the pioneers of laboratory phonology and a world-renowned expert on intonation. Her excellence in research has also been recognized by the European Research Council. She has been awarded with a very prestigious ERC Advanced Grant to work on a project entitled Speech Prosody in Interaction, the Form and Function of Intonation in Human Communication. The title of her talk today is on the phonetics and phonology of a high star and the low plus high star in English and Greek. Okay, Amalia, the floor is yours.
Thank you, Yaya, and thanks everybody for joining in, and to the organizers of Abraling ao Vivo for inviting me. I think this is a really great forum. I will share my screen and start the talk in this way. The talk is about the phonetics and phonology of high star and low high star in English and Greek, as Yiya mentioned. And before I begin, I would like to thank a number of people and funders. The work, as Yiya mentioned, is funded by the ERC grant called Sprint, which would not have existed, I think, without Kent Startup and QR funds that allowed me to do the initial work that led to the grant itself. There are also several people who have worked with me in this research, and I will single out Katie Jepson, Catherine Marco, and Song Zhang, who are the people who have behind the data that you will see today on the English side. Data which would not have existed without Lucy Barrington, one of our master students at Kent, who actually did the recordings. And on the Greek side are Yero Katsika and Georg Loffing, who have been instrumental in starting this work with me. So now I mentioned high star and low high star, and these are terms that you may or may not know, and I will not take it for granted that they are known, because I know that there are students possibly in the audience. So I would like to explain a few introductory concepts before I delve into the actual research. So what are high star and low high star? They're abstract phonological representations of two pitch accents that are both said to be part of the intonation system of English and Greek. And the terms come from the autosegmental-metrical analysis of these intonation systems. So there are three terms here, pitch, accents, intonation, and AM, that I would like to say a little bit more about. So first of all, what is intonation? You may think, why do I bother to do this? One of the reasons is that there is, the term is used quite extensively these days, and not always in the same way. So I want to clarify first what it is I'm talking about. So when I say intonation, I mean a language-specific and systematic modulation of F0 that applies to utterances. The domain is the utterance, not the word, for example, as with tone. And these modulations have some grammatical function. Typical grammatical functions include marking phrasal boundaries and encoding pragmatic information of different types. This could be sentence modalities, so whether something is a question or a statement, but it can also be the intonation encoding of focus, as well as implicatures and generally inferences that we make, not about what the speaker intends when they use a particular utterance. To give an example, I can say my ex in at least two different ways, there are many more, as a response to who's that, or as and or in order to indicate my surprise that my partner, for example, has invited their ex to my party. So here is what they would look like. Um, this is just me saying my ex versus, which is um, the one at the top, versus my X, where the pitch goes up at the end. Now, one of the things that I want to make clear with examples like that is that I will not be using intonation as a synonym for F0 or as a generic term for all functions of F0, but rather for these particular functions mentioned here. Intonation is just one of the functions of F0, and intonation itself is realized primarily with F0, but with other exponents as well. And part of the talk today is to show what other exponents of intonation we can consider. So how does that fit with the AM model? Well, the AM model, which I will present in a nutshell so we can follow because the rest follows from that, is a model that tries to account for one of the most vexing questions about intonation, which is the following. Pitch contours vary substantially from utterance to utterance. So, and this applies even when listeners recognize them as instances of the same tune. If that is the case, the question that arises is how do speakers learn to do this? And how do they learn what is a tune and how the tune works with utterances of different lengths, for example? And to show that this is what happens, I'll illustrate it with an example here. On the left, you have a long utterance. This is what it sounds like.
A ballet dancer.
Hope you can hear it. Can we give it louder?
A ballet dancer.
Versus the short one.
Lee. Lee.
And I hope you can tell that they are both intended as very comparable instances of somebody expressing surprise. For example, they could both be responses to you learning that your friend from high school, Lee, who was a klutz, turned out to be a ballet dancer. And you can respond to that by saying a ballet dancer or Lee. Now, if we look at the tunes themselves, they're not identical. So the tune for a ballet dancer has a low level stretch, whereas the one for Lee doesn't have that. It just has a very quick dip. Um, so these differences are differences that AM says are due to are systematic and due to linguistic context. What Bob Ladd would have called lawful variability, and which I provided a long list of in a 2016 paper. Okay. Now, what is important here is that in order to understand this difference, we must understand that the tunes are made up of distinct components. We cannot see them, in other words, as configurations. And I'll try to illustrate that for you. So when I say there cannot be configurations, I mean you cannot take the contour and stretch it or shrink it to fit the segmental material that you have. We can see that if we take the short tune, just duplicated the line, and stretch it out to fit the long one. Okay? And we can hear what this sounds like. This is the original.
a ballet dancer,
And this is what it sounds like when we stretch the short tune.
a ballet dancer,
Okay, so it sounds kind of odd.
a ballet dancer,
Okay, and as if the emphasis is on whether she's a ballet dancer, not a jazz dancer, for example. Now, this may seem like a crazy exercise, but this is pretty much what the British School of Intonation has been traditionally doing. So when I was a master's student way back in the previous century, we had to learn intonational tunes using monosyllabic utterances like yes, no, and then try to somehow apply them to longer utterances. But it doesn't work like that, as this example shows. The same applies if we actually do the opposite, if we take the long one and put it in the short one. So here is the original Li
Lee,
versus,
Lee,
okay? Now you notice that the difference is not as great. It does sound lower, so phonetically it sounds lower, but it doesn't sound particularly different in terms of meaning. And one of the reasons is that because Li is one sentence long, we cannot move the different parts of the tune onto different syllables and thus affect what the tune means. Okay? And this is the critical insight from AM. So, how does AM account for this? Well, AM says that phonologically, the tunes that we hear are made up of strings of discrete low and high tones. And these low and high tones can be concatenated in different ways depending on the language. And critically, they don't exist on their own. Very often you see these strings on their own, but the critical point is that they are associated with metrical structure. So the name of the theory, coined by Baudelaire, comes from autosegmental because it assumes that the tones are independent of the consonants and vowels, okay? They're autonomous segments, and metrical from the fact that the tones associate with structural positions in the metrical structure. Um, so they don't exist in a vacuum. You need to know that association. And this is part of the learning that you do in order to be able to produce these tunes properly. So here is an example of one possible prosodic structure for a ballet dancer that we saw earlier. What you have is the prosodic tree at the top. Okay, so a ballet dancer here. And you can think of this part as being a plane, like a sheet of paper. The lines underneath indicate that the tone tier is separate from the prosodic structure itself. So you can think of it as two sheets of paper connected. And then we need the association lines that tell us where the particular elements of that tune are going to go. So specifically here, we see that we have a low star high. What is that? It is a pitch accent, a deliberate pitch movement that will be associated with a metrically strong syllable. In this case, since it is the only accent, it has to be the strongest syllable in the entire utterance. And at the end, we will have the high boundary tone, the one with the percent, that is associated with the IP, the highest level in the structure, and in between the low phrase accent that you see here. Not everybody agrees with this exact structure, but I think the general principle is the same for anybody who does AM. Now, how can we go from this abstract model into phonetics? This is the traditional view. Phonetically, these low and high tones are realized as tonal targets. What are tonal targets? They're local minima and maxima with zero, and they are defined by their scaling, how high and low they are in pitch or zero, and their alignment, how they synchronize with specific segments. And the rest of the tune is derived by interpolation, so we don't have to define it even in the phonetics. So if we look at the same tunes we had before, the they both have the same phonological representation, okay? And this is what connects the two, what tells the listener they're the same thing, okay? Or the thing that the listener infers as a learner when they hear these tunes, but they are aligned in different ways with the vowels and the consonants of the utterance because of the difference in prosodic structure. In Li, you have only one syllable, so the only thing you can do is just make each one of these tones into a tonal target and have a rise, fall, rise in there. And the little dots tell you where these targets are. If we look at the longer utterance, okay, the low star high is going to be realized on the accented syllable of ballet, okay, because that's the association. The high boundary tone will go only at the last vowel, and that means that the low phrase accent will spread to cover the area, the stretch in between. Note that in this model, the drop here is actually an epiphenomenon of going from one high to a low. It's not part of the representation, according to this view. So hopefully now we have an understanding of what the system is like, and we can start looking at the English accents, high star and low high star. Now, these accents were originally posited as a contrast in Pierre Hambert's thesis in 1980. The canonical representation, if you like, of prototypical instances of these accents are something like this. If you think of the gray rectangle as the accented syllable, the high star will be high pitch on that syllable, whereas the low high star is meant to start with low F0 and reach a peak on the accented syllable itself. About 10 years later, Pierre Hambert and Hirschberg provided a formal account of the pragmatic difference between the two accents. They argued that the high indicates that the accented item is new in discourse and should become part of the common ground. So this is couched in terms of having a speaker and a hearer and a common pragmatic ground where they share information. So if you highlight something with a high star accent, then that means that this is new information that should be added to the common ground. Of course, it has been shown since then that accents can be ornamental. I think this is the term that one term that has been used. Sasha Calhoun showed that these accents can actually be also used with given information for metrical reasons, but by and large, that distinction holds. Low high star, on the other hand, encodes contrastive information. What does that mean? It means that there is an implied closed set of alternatives, or perhaps openly known, and the accent tells you which one should be put in the common ground. Now, the terms broad focus and contrastive or narrow focus have been used extensively for these accents from the intonation perspective. So in this system, we have a difference in how the accents are realized phonetically that associates with differences in information structure indicated by the accents. Not everybody agrees with this analysis, however. So Bob Ladd, and I've just shown here the International Phonology book, but there are several publications of his with a number of colleagues relating to this matter. But by and large, he argues that there is no distinction at the phonological level, and the two accents, the difference between the accents is one of emphasis. In other words, the rise that you get to see in the low high star is due to the fact that you have expanded pitch span. So because you use the accent when you're being emphatic, you increase your pitch span and the rise becomes more salient. There are even other views, like those of that of Wussenhoven, that such accents are not actually rises but falls. Okay? The data here do not speak to that, so I will leave it out for the moment, though in Sprint, our intention is to look into this issue as well. Now, This is complicated enough, but there are additional complications. Pierre Humbert, first of all, argued in 1980 that high star may actually have low F0 as a result of what she called sagging interpolation. And this is a nice illustration of that from a paper by Yi Chen and Yi Shu. So the linear interpolation that we typically expect in AM would be a straight line between the two high accents. However, the sagging interpolation is the dip that you see here. The sagging is meant to increase as distance between accents increases, but Ladd and Shepman, actually looking at British English, argue that actually that dip is very consistent. And in fact, they use this as an argument to say that there is a low phonological, underlyingly phonological low in this case, and therefore we shouldn't call any of these accents just highs, but low highs. So independently of which way this goes, the general point is that the neutralization transmedially is possible. There is also neutralization in the absolute beginning of utterances. So this is, for example, instructions that come from the two versions of the Toby system for American English that say if you find an accent that is high at the very beginning of an utterance, you should annotate as a high star because the contrast with low high star is neutralized in this position. And the reason for that is that transcribers had great difficulty distinguishing the two. Now, this suggests that this is a very muddy area, but there are some issues. First of all, the evidence has pretty much, at least from the perspective of speech production, has focused primarily on F0, and sometimes even looking at the height of the peak, not at the height and the alignment of the peak. However, we have now a lot of research from different languages. The languages here include German, Polish, Greek, and yes, I think that's it. That intonational contrasts affect the realization of segments, and these effects can be seen as enhancing the tonal contrast. So we need to look into that for these accents. Further, the evidence that we have compares different dialects of English, and this may not be optimal because by and large, English dialects share systems like you would expect, but they're not identical. Okay? So it could be the case that in the same way that northern varieties of British English do not have the contrast between luck and lack, luck and look, in the same way you don't have a distinction between two accents. And some old data with Gina Garding suggest that this may be the case. So back in 2003, it was published in 2007, we looked at the accents we're dealing with here now. I have to stop that. In Minnesota and in Southern California. Why these two varieties? Because Gina Garding is from Minnesota, and she felt in the seminar that I was teaching then at UCSD that she didn't share the intuitions of the Californian speakers. So we had participants read a dialogue in which we wanted to have them do 4 different levels of emphasis. And this is what they did with Raymona, and they were always using the name Raymona. We use Raymona so that we can see the dip at the beginning if it's present. Here is what the Minnesotans did.
Ramona, 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 Ramona.
Okay, I hope you can hear that.
Ramona, 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 Ramona.
And you can see it and hear it. It looks identical except the pitch range and possibly the duration increases. Here's what the Californians did. They had two patterns. One they used when they were doing folds and one where they were doing uptalk. So this is the folds.
Ramona, 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 Ramona,
Okay.
Ramona, 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 Ramona.
Okay. So you can see that as you go along and you get into the really emphatic one or contrastive one, as a matter of fact, in the dialogue, you actually get to see a dip that is not present when you do just new information. And they use this accent they when they were replacing uptalk. So here is the entire dialogue for them. So,
Who was on the phone? Ramona. Who? Ramona. It was who? Ramona. Raymond. Ramona.
okay. So they would uptalk except when they really wanted to be very insistent and corrective, and then we would use the accent that had the dip. The way we interpreted this data is to say that the Minnesotan speakers indeed didn't have the contrast between high star and low high star, but the Californian speakers did. Okay? And this could, of course, apply to other varieties as well. So, because of the, some of you, especially if you work on intonation, you may think, why is this of interest? And I have had reactions like, oh, no, not this again. Um, I think it is still a very interesting topic, even though in a lot of the most recent work that I see, it's something that has been largely forgotten. So I've looked at publications for the last 15 years. It's rarely mentioned as an issue. And psycholinguistic literature, either as well as literature from the syntax phonology interface, either says, we don't know if there's a difference, forget about it, we'll just put them all together, or takes the distinction for granted. Okay, so why do I think after all this time that we can go back to it? I think that it's important for elucidating a distinction between what is gradient and what is categorical in intonation. This is an issue with which we have grappled for decades without any resolution. And this is a good case to try again. It is also a case that can help us try to refine models and analysis methods. Okay? I think it is also important for English. We need to know to have a descriptively adequate understanding of what the English intonation system is, and be able to actually map dialectal differences rather than giving up. It is also important to understand this because the distinction is directly linked to issues of focus, information structure, and pragmatic distinctions. So we can neither take it for granted nor dismiss it altogether. So based on that, we had a few research questions to start with. Is there a distinction in standard Southern British English? Okay, which is, you can see it as the modern development of RP. And how is this phonetically realized, if it exists? Is the contrast neutralized in utterance initial position, absolute initial position? Is there second interpolation for the high star? Or is Arlad and Shepman right that the dip is always there? We don't have a lot of data to actually test this point, so I will leave it for, we left it for future research, but we have it in mind, and you will see some data that actually relate to it. Okay, so these were the major things. And finally, I will briefly present the Greek data to show you the contrast with the language in which the distinction is actually considered to be valid. There are no disagreements on that, and has been empirically supported by research. And in fact, as a native speaker of Greek, because this is such a salient contrast for me, I find it very hard to believe that it doesn't exist in English. And this is perhaps one of the reasons why I wanted to work on it so much. So, what did we hypothesize? And this is where the gradient categorical thing comes in. So, Pierhammer and Hirschberg suggest that these, the high star and low high star, are distinct accents. Okay? If they are distinct accents, then what we would expect to find phonetically, whether we're looking at F0 or perhaps other parameters, is something like this. The accents will have distinct distributions. there will be overlap. The idea that there is no overlap and you will never find an accent that you're not sure how to categorize is just a fallacy that comes from looking at very sanitized data. In real data, we didn't expect to see that, but we expected to see this kind of pattern. Okay, so each accent would vary based on elements of what we've called before lawful variability. On the other hand, if LAD is right, then high star and low high star should form an emphasis-based continuum. If that is the case, then we would expect something like this. We would expect to have one distribution, and we would expect the accents that we can easily categorize as high star and low high star to be at the edges of that distribution. Okay, so most of the accents should be somewhere in the middle and should be very difficult to discriminate. Okay, and any variation that we have should be related to emphasis rather than information structure, for example. And in that sense, this is an example of what Bollinger calls gradients. And I put paralinguistics in brackets because that's my term. So that kind of gradients is not the same kind of gradients that you find within the separate distributions of high star, low high star that you see on the left. Okay? But it's something that will mean, the more you create a dip, the more emphatic you are. Okay? So more concretely, in terms of our data, from the pure Humbert and Hirschberg side, we expected that we will not find differences in F0 in absolute utterance initial position. So if, for instance, you had a dialogue and you said, "What's your name?" Rory. That's new information. That's a high star. Was that, or you could have another dialogue that would be, "What's his name?" Bobby Ney. No, Rory Ney. Okay, that would be a low high star, and they should be identical. Okay. In non-initial position, however, we would expect the accents to be distinct. So go under the barn should be different from go under the barn. If the analysis is correct, right? And as noted, the dip in the accents that are high stars should be lower with increasing distance from the preceding accent. On the other hand, if LAD is right, the accents should not be distinct, very simply. Prototypical accents should be rare because they are at the edges of the distribution. And as I mentioned earlier, they should be associated not with distinctions in information structure, but with emphasis. And one of the things that we want to look at, there was no time for that, was to see if there is indeed a difference in terms of pitch span. I will have something to say about that later on. And perhaps speaker ratings. So you would expect that accents that are more low high star like would be rated as more emphatic. Okay, so these are the hypotheses associated with the two different ideas about these accents. So what did we do? We had 8 participants. This was our pilot for the large study. It happened during lockdown, and we have not been able to collect any more data. That's why we are dealing with these 8 speakers, but I hope that very soon we can start proper recordings again. Our speakers were from the London metropolitan region, or Greater London, which is the blue area that you see here. The data that I'm discussing here are part of a larger data set. So these same participants produced more data than what we see here. And they were all recorded in a home in quiet conditions. By the time we could start recordings, the University of Kent was closed. So the lab that we had built was not, was out of bounds for us. So what did the data involve? We had, first of all, mini dialogues that were scripted, and the aim of which was to elicit narrow or broad focus. So, for example, what's their name? Lou. Is their name Rory Bay? Rory Ney. Okay. So so the capitals show you the low high star situation or the expected low high star, and when no capitals are used, the expectation is that this is new information encoded with a high star. Participants also used story cubes. If you're not familiar with this game, you have a number of dice, and participants throw the dice. As you can see, the dice have different pictures of them, and then they have to create a story based on the dice that they have. And they can be crazy stories, but they actually do provide instances of given and new information. We also use map tasks to encourage, again, use of contrastive and new given information. In case you're not familiar, what you see here is two map tasks, two maps. The instruction giver has a path in their map, the orange line, and has to give instructions to the follower so they can replicate the path. But the maps, as you can see, are not identical. So this, and since the two participants cannot see each other's maps, they need to negotiate quite a lot about what it is that is on the maps. And these were the data that have been analyzed so far. So what we did is orthographic transcription followed by forced alignment, correction of the forced alignment, which is painstaking, and annotation using AEM. Now, the AEM annotation we used was not based as is often done on people saying, this sounds like a good high star, this sounds like a good low high star, because that is circular, because you're just confirming your own biases about what you expected to find. Instead, we base this on context and pragmatic criteria. So basically, for anything that was deemed accented but was new or given, it was given a high star. Anything that was explicitly or implicitly contrasted, it was given a low high star. So for example, if somebody said, go above the lake, okay, even if the lake and above were mentioned for the first time, the assumption would be that they were trying to juxtapose going above the lake, through the lake, or under the lake. Right? So this is a closed set, and you're telling your map task participant which way to go. So that's a low high star. And this indeed created a lot of discussion in the group because Tsong and Katie, who were doing the annotation, will come to me and say, that doesn't sound like a good high star. And my argument has been, that's exactly what we want, not good high stars or low high stars for that matter. So the things we excluded were utterances that were accented with the right accent but had up talk, because that meant that the shape of the overall chin would be different, as well as cases that clearly belong to a different category, like a low star before up talk, both of which are possible patterns in SSB. The analysis window we used, and this will become clearer shortly, was the prosodic word. And so in the examples that you see here, the words that in red would be analyzed as one altogether. So we wouldn't be looking at the accented syllable only. And based on that, we had actually a modest sample of 742 tokens. I thought this was a small sample. Then I saw today a very well-known study that had 300 tokens. So I think we're doing okay. But we hope to increase that dramatically. What you see in the table is the data separately for dialogues, cubes, and maps, and you can see the distribution of accents in each. As you can see, they don't all contribute equally to the overall sample, and the distribution of the different types of accents is different as well. So the maps give us, for example, a lot more low-high stars. Now, I hope you're curious about the data. So here are some of the data. Some examples, and I'll play them for you. At the top, you have high stars. So here is one.
Molly.
Versus the low high star version of that.
Molly, Molly, Molly.
Okay, as you can see, if we were probably doing this only by ear, we would be annotating them the same way. We chose to do it differently because they were in different contexts in the dialogues. Here is another one.
The grey raven.
I'll try to make it louder too.
The grey raven.
The grey heron. The grey heron.
Okay, where heron and raven have high star accents. And here is a low high star.
A grey heron. A grey heron.
Okay, so a grey heron, not a grey raven. Okay. So this is probably already giving you an idea that the distinction is not dramatic. And that's what came up. So traditionally, if we were doing this work, we will be using tonal targets. We would be looking for the low and the high and where exactly they go. Now, sometimes this is very easy. So if we look at the Minnesotan data I showed you earlier, we can easily see two tonal targets with our eyes closed. If we look at the so-called data, on the other hand, there is no easy way of telling where the the low is in particular. And even with algorithms, it would be rather difficult to find it. So we didn't want to do that. And we knew from other research on Greek, the data we'll show you later, that we can miss important information if we actually look just at the tonal targets. So the analysis we did was functional principal component analysis, which we have shown works quite well. Now, why did we use functional principal component analysis instead of using, for example, GAMS that other people have been doing? There are a number of reasons. What I find appealing about it is that it allows us to capture dominant modes of curve variation. And when we do that, we can use the principal components. We can think of them as together making up the shape of each curve. And in functional PCA in particular, the contribution of each component to the creation of the original curves is represented as a coefficient or a score and can be used for statistical analysis. You can think of these scores as, to paraphrase Michele Gubian, as saying something like, in order to recreate this curve in your data, take 3 pinches of PC1 and 4 pinches of PC2, something like that. Okay. What did we use it for? We used it for F0 and RMS energy curves, which we extracted from voice source. They were all scaled by speaker, linearly normalized for time. And for those of you who are into this, you see the smoothing parameters, which were selected by trial and error to make sure that we capture important linguistically related changes in the curves, but not microprosodic variation. We also use landmark registration, which was the onset of the accented syllable, because we wanted to see, according whether AM assumptions about where pitch events occur, how they would pan out in this case. So what is landmark registration? You can see a bunch of curves here, and you can see they can be very variable. The dots tell you where the accented syllable starts, and this is what landmark registration does. It lines them all up at that point, the onset of the accented syllable in our case. Okay. We also looked at the duration of the accented syllable. We originally wanted to treat this as a curve as well, but because in some cases our analysis window was too small that for durations of individual segments or syllables to create a curve, we were not able to do that. So the idea behind using seeing everything as a curve is that then you can do an fPCA of the PCA curves. But I will stop at this point. Okay. What did we do statistically? Statistically, we used the scores of fPCA to examine if there is a difference between high star and low high star. The analysis was done separately for two groups: accents in utterance initial position, And the reason for that was that we could not do landmark registration for these, and non-initial accents, anything that was not on the very first syllable. Okay? Because the accents that are non-initial, shown with the N, have landmark registration, whereas those with I cannot have that. And this is something that we are reconsidering. In our models, the fixed effects were the accent and the task, and whenever possible, their interaction. I think the task should be treated as random intercepts, but models did not converge, so for now, these are the models that we have. What did we want to see as dependent variables were the first and second PCs of the fundamental frequency and the energy curves and the accent syllable duration. In addition to these traditional, at this point, models, we actually use random forest to see what parameters, if any, can help us, can predict which accent we have. And our predictors were PC1 and PC2 of F0 and energy curves, as before, the duration of the accented syllable, and the task. Okay, and I will unpack, hopefully, these as we go along. So here are the data at a glance. What you see here is average curves, not fPCA curves. Okay, so the green is always the low high star and the red is the high star. So you can see that there is a small difference in shape and height, with low high star being lower when it comes to F0, but higher energy. These are all the initial ones. When accents are non-initial, we see on average, there is a small difference in the shape of the F0, such that the low high star accent has a dip. Okay? And but no differences in terms of energy. So how did this pan out statistically and with PCs, first of all? So here is the F0 accents in absolute initial position. As I mentioned, there is a difference in height. And this is captured by PC1 that represents 66% of the variability in the data. To make this clearer, the black line is the average curve from all the curves in the model. The plus line represents what happens if the coefficient for PC1 is +1 standard deviation of the average, and then the minus line, what happens to the curve if the coefficient for that PC is -1 standard deviation. Okay. So I hope this is clearer. Now, what did we find? We actually found no accent effect in either PC1 or PC2, though PC2, as you can tell, does show a difference that I would associate with low high star, something that starts low and rises, versus something that's kind of falling, which I would think of as a high star. But statistically, there was no difference. The only difference we found was that PC1 was higher in the unscripted tasks, which is an uninteresting result. It just tells us that when people played a map task game kind of thing, they would be more animated than when they were reading boring scripted dialogues. Okay. So no effect in F0 in absolute utterance initial position. What about energy? On average, we see the low high star has higher energy, and this is captured by PC1 to a very large extent. And in fact, this is statistically a difference that we found. So PC1 is higher for the low high star, and they suggest that low high star accents are likely to be louder than high stars. Okay. What about syllable duration? We do find a difference, and you can see the difference here. It's on average about 40 milliseconds, but it didn't reach statistical significance. I believe that this has to do with the fact that we're dealing with largely natural data, so there's a lot of variability in the data set, and we didn't have enough data to actually have enough power. But there is the difference in the duration of the accents is in the right direction. Now, what happens in non-initial position, which is where we expect to see the biggest difference? As noted, on average, we do see a dip in the low high star accent. And this dip is captured by PC2 in particular. You can see here that if you have negative values for PC2, you actually get the dip. Okay. How did this pan out statistically? This is exactly what we found. So for PC1, there was no difference. You can see that PC1 captures not so much shape, but the difference in the scaling of the accents. But PC2 that captures shape was indeed lower for the low high star. We can see it here when if you look at the three green bars that show you the low high star coefficients for PC2 in the three tasks, they're consistently lower than those for the high star. Okay. So that tells us that there is indeed a difference in the shape of the accents. And the arrow is there to show you where the beginning of the accented syllable is and how that low PC2 captures the dip at the beginning of the accented syllable. For energy with non-initial accents, we didn't find any effect. The differences have to do with task, not with the accent, so I won't have very much to say about that. The other thing we found was that accented syllable duration in non-initial position was statistically longer for the low high star accent than the high star accent. Okay? So it is the same distinction that we saw before in initial position, but this time it reaches statistical significance. The change is comparable, about 40 milliseconds, but here we have a much larger sample. Okay, so that's why I think that the difference in duration is actually real. So what can we say about all of these things? The distinctions in absolute initial position are due primarily to energy, possibly to duration, not F0, though PC2 suggests that it might be, and we'll come back to it. The fact that we have these differences in energy between the two types of accents suggests that people are trying to create a distinction, okay, in some way. In the non-initial position, the distinction in terms of shape is there. We see that the high star does not have a dip, whereas the low high star does. But we have to bear in mind that PC2 explains only 24% of curve variability. So it is evidence, but not the most striking evidence one could have. Now, we've seen that there is this difference in PC2, and there is also difference in duration. Could the two together be able to distinguish the accents? Well, this is the data that Song Tsang sent me this morning, and I'm really grateful to her for doing this at the last minute. You can see that the accents are not clearly separated. What you see is their value in PC2 plotted against the duration of the accented syllable in milliseconds. They're not completely distinct. They overlap quite a lot, but they're not identical either. So we have data from vowels in English varieties that are not very different from what we see here. So overall, we have some evidence, though it is not the strongest. Now, one of the things that we wanted to see is whether we can do the reverse, see what parameters we can put into a model to see if we can predict the difference between accents. And for that, we used random forests. Again, we had to look at type I accents and N accents separately because the models are different, so we could not put the coefficients of the PCs together because they are the outcome of different analyses. This meant that we lack power for now. The total number for the utterance initial accents was just 119, whereas for the non-initial accents is over 600. In both cases, we did very similar things. 70% of the data were used to train the model and 30% for prediction. Because we had this unevenness between high stars and low high stars, we used oversampling to create even samples of high stars and low high stars in the training set. Okay. And what was put into the model were the PC1 and PC2 of F0, the PC1 and PC2 of energy, the duration of the stress syllable, and the task. So what do we find? Here is the outcome of the analysis for the initial accents. I've highlighted what I think are the most interesting results. How accurate was the model that was trained on this data? We can say about 64%, but if we bear in mind that the no information rate is almost 53, that's only an 11% improvement. What does this mean in plain English? If in the test set everything had been simply marked as a high star, we would get it right 53% of the time. So going 11% above is not really groundbreaking, but it is an improvement. Clearly something is different. What is of most interest to me was that the validation of the role of the difference in energy. The higher this index is, the more that predictor contributed to the correct identification. And remember, we said that these accents, the low high star accents, are had higher PC1. I think the task is just an artifact of how the accents were distributed among tasks. But the other interesting thing is that the PC2 of F0 comes out as the third strongest predictor. Okay? And if you remember, PC2 did not come out as being statistically significant different for the two accents, possibly because of lack of power, but it does show a difference in the shape of the accents. So this suggests that speakers are trying to make that kind of distinction. When it comes to non-initial accents, we see surprisingly and disappointingly, I should say, a lesser improvement. Task comes out as being the most significant predictor, but again, I think this is an artifact because the distribution of accents was different by task. But at least what we get is that the second strongest predictor is PC2 of F0. And again, as a reminder, this is the component that tells us the difference in shape. So the second best predictor is the difference in shape. So overall, what we get from the English data is modest evidence in favor of a contrast. It's not overwhelming, I wish it were. So the jury is still out, but I think the evidence points towards there being a contrast. Because this is not very great, I thought, what about the Greek data? Let's see the Greek data where we know that this contrast exists. So this was in the description of Arvaniti and Baltazani. That's the Greek Toby. And in that description suggests that the phonetic realization and the pragmatic function of these accents in Greek is very similar to what Pierre Hubbard and Hirschberg suggest for English. We have evidence from Loffing et al. From 2019 that they are distinct in terms of the shape, in terms of the pragmatic context in which they appear, and not just like, and the additional thing is that the difference is not just one of peak height, which means that the difference is unlikely to be attributed to emphasis. So overall, the Greek data seem to go in one direction. They're much more consistent. And I'll show you some data. The data are the data from 2019, but they're actually supported by our pilot data right now, except we don't have enough to actually do a full analysis. So what you see here is the original data from 2019, and what I have highlighted is two instances of the same word, the word for gold. and what it looks like and what it sounds like in Greek. So here is one. Focus at the end, malama.
Πήρε μανικετόκουμπα από μάλαμα. Πήρε μανικετόκουμπα από μάλαμα.
Versus.
Ήταν μανικετόκουμπα από μάλαμα. Ήταν μανικετόκουμπα από μάλαμα.
Okay, and I put the two accents together so you can hear the distinction.
Μάλαμα, μάλαμα.
Okay, so the shapes could not be any clearer, and it is very different from English. Here are some data. Focus on the last word when you listen from our map tasks now.
Το ορόσημο ερημωμένος νερόμυλος.
Oops.
Δεντρογαλιά. Δεντρογαλιά.
So these are high stars, and here are the low high stars.
Όρημα λεμόνια. Όρημα λεμόνια. Μέσα από το ορόσημο αυτό. Μέσα από το ορόσημο αυτό.
And as you can see, you can hear those low high stars even in absolute utterance initial position. So for Greek, there is no doubt that this is a real contrast. And this comes out in the analysis as well. So what you have on the left is the average contours again, red for the high star and blue for the low high star. You can see very clearly the dip and rise fall. And we can see that, and also the difference in the height of these two axes. And this is captured by PC1 and PC2. So PC1 captures the difference in the height of the accents and where exactly the peak occurs earlier for, if there is a peak, for the high star and the low high star. And PC2 captures the shape of the difference in the shape of the accents. The result is that in Greek, we can actually separate the two actions. If we put PC1 by PC2, it becomes very, very clear that they are distinct. So the zeros here show you if the PCs are positive or negative, and you can see that the high star accents are all concentrated on the lower left quadrant, and so they have low PC1, low PC2, whereas the blue accents, the low high stars, are all over the place for PC1, so height is not that much of an important predictor, but they are largely on the left side, positive side of PC2, so they have the shape. And this allows us to think of the high star as a low fall and the low high star as a rise fall. I wanted to put there the density plots for the PCs, and we can focus on the red and blue, and red and blue again here, just to bring home the point that although these are statistically significantly different for the two accents, there is quite a lot of overlap. So we should not see overlap as a marker that the accents are not distinct. Okay, so this is the Greek data, which are very, very clear. So what can we conclude about all this? The putative contrast in English is not completely neutralized, even if we are in absolute utterance initial position. We see that it's reflected in this position mostly in energy, but F0 and duration play a part too, albeit not very strong, possibly because, as I mentioned, we had a small data set and the data are very variable coming from natural speech. So we lack power. In non-initial position, there is evidence that there is a difference in F0 between high star and low high star along the lines predicted. So a dip for the low high star that is not there for the high star. And we've seen that this is enhanced with differences in duration between the two types of accents. So overall, it seems to me that the data weakly point towards a contrast. And the contrast does involve F0, and duration and energy seem to enhance it. And this could possibly mean that there is some Q trading, with Qs like energy becoming very important in the initial position where the F0 Q is missing. What I find very interesting that scaling did not seem to play a role. So the suggestion that this is a matter of emphasis would indicate that we would see more differences in the scaling of the low high star. So we would see a difference such that the high star has low F0 and the low high star has high F0. This does not happen. Anything that we see has to do more with shape and other elements. And this is one of the reasons why I'm inclined to believe that this represents more a phonological contrast rather than an emphasis continuum. However, of course, this is not conclusive. A lot more work is needed. We need more data that are even more varied in numbers in terms of tasks and speakers. And we need a very large sample in order to reach a conclusion. We need fine-grained analysis to look at individual variation, something, for example, that Grice and colleagues have been doing for German. It could be the case that some speakers realize have the contrast and others do not. We need to explore further the issue of prototypicality. Do accents that phoneticians agree are high star versus low star at the edges of the distribution, or are they very frequently found in the data? We need to look more at sagging interpolation and the role of emphasis, see if we can have speakers rate those accents for degree of emphasis. And of course, we need to validate from a perception side the enhancing cues and cue trading. Now, we know from a lot of eye tracking experiments that American speakers do differentiate these accents, but we don't have enough from British English about that. So in general, what can we conclude? We can see that it is possible to combine the insights of AM with newer methods of examining and modeling data. And despite some problems that we have encountered with some logistical issues we've encountered with fPCA, I think it is a good way of looking at the data because it allows us to stay true to some critical insights of AM about tonal alignment, while also looking at taking a more holistic view, if you like, of the pitch contours. Now, one of the things that we found very clearly is that this kind of research requires a lot more data than the traditional idea of having a few speakers read scripted data and taking the traditional tonal target approach. I know that this can be daunting, but I personally find it very exciting and very positive development because I think it provides us with a lot of opportunity. It allows us to treat international categories in a similar manner to other phonetic categories. We can see a gamut of variation and realize that this is how it is. Instead of having this sanitized view where you have four speakers who are your buddies and they produce the same scripted material, and lo and behold, your accents are completely distinct. This does not apply in real life, does not apply to any other phonetic categories, and it is time we started seeing intonation in the same way as the rest of phonetics and phonology. By doing this, we can also document variability in intonation better. We can see what variability there is out there. And hopefully, we can start disentangling categorical for graded aspects of F0 use, which I hope to be doing in the next couple of years or so. And the other thing is to allow us to actually start to see the contribution of other phonetic parameters before F0 to the realization of tonal categories, rather than insisting that everything has to be encoded in two parameters of F0, scaling and alignment only. So if we do all of these things, I think we can also start avoiding circularity, especially if we bring pragmatics into our categorization and annotation criteria. And this will allow us to stop searching for prototypical instances alone and look again at how variable tonal categories can be. So I hope that I have convinced you this is a difficult but exciting way forward. Thank you.
Thank you very much, Amalia, for this wonderful talk. I'm still waiting to see some questions typed into this chat box. Meanwhile, I will take advantage of the opportunity that I have as the organizer here. No, not the lead. I have a clarification question. For the English data, when you look at the noun initial position, you do see some kind of contrast in terms of F0, right? And you also see durational contrast. There's a durational difference. I was wondering, did you look into the correlation between the lengthening and also the pitch height or alignment?
The one thing that we looked at right now, because the data are really, really new, is the correlation between the duration of the accented syllable and the coefficients of PC2 for the non-initial syllables. We haven't done it for the initial syllables.
The non-initial, because I know
the non-initial, yes, that's the that was the one that showed the two ellipses. But yeah, I think if we would need to create multidimensional models to see that. That's why we went for the random forest, to start from the bottom and say, okay, what can predict the accents
I see.
better? But I agree with you that I think that all of these elements probably work synergistically. And this is something that we should start looking into in more detail.
I see.
The trouble is that this would create multidimensional models that are very difficult to interpret after a while. So
yeah, but it is sort of really nice that you show the real contrast between English and Greek, right? In Greek, you really have a clear difference.
You can see it, yeah. You can see it and hear it. So.
Yeah.
But it could be that this is an incipient difference. It could be that there is no difference at all. That sort of, or that it's a difference that some speakers have, but it's actually a marginal contrast that not everybody has. But I think we really need to have a lot of speakers and a lot of natural data to see if it really happens. Because if we look at only small numbers of participants or scripted data, we don't know if we can get.
And do you think that there might be also the possibility that some speakers have a clear contrast, but others don't?
I think so, yeah. I think we need to look more into what happens there. Why would some people acquire this and others will not? Because normally, right, if you have a contrast in your variety, you end up acquiring it, right? So you may not have a contrast between look and luck if you are from the north of the UK, but otherwise you do. So why would you not acquire this? Right. This is why I'm inclined to think it may be more like a marginal contrast in English.
I see. Yeah. And when you wish, let me just double check if I have any questions in the chat box first. Do you have access to the chat website? No. Yeah, so the other question that I have is about the California, the Southern California and the Minnesota. You showed several tokens, right? And then you sort of see some kind of gradient increasing, if the contrast. What do you think about cases like that? And if you lump them together and do the same analysis, then you are going to see more marginal type of contrasts, right?
Yes, well, we don't have enough data from that variety, so I don't know. I was thinking about that. So I would say that maybe your intonation system doesn't, like, if you're from Minnesota, your intonation system does not make a distinction between those two accents. So you have to use other means to actually create the distinction that you want to make. That is one possibility. In California, and I think you find that the speakers have either something like it's high or they make the distinction. Now, for me, the question is, what do you do if you don't have that distinction in your system? How do you encode the information structure aspect that you want to have? Yeah, I don't know. I think this is something that needs to be looked at, and this is something that we intend to look at with UpTalk. So there's supposed to be varieties of English that have historical UpTalk, right? That you're supposed to be doing your statements with that. If that is the case, and if UpTalk has other functions, what do you do to incorporate those other functions into your intonation? So when you talk, what do you do? So if UpTalk does not encode in any way, that you're trying to mitigate what it is that you're saying, how do you show that kind of mitigation? I don't know. These are things though that I think these are the things we should be concerned with.
Well, in some contexts, I guess, if there's clear contextual information, then maybe the prosodic manifestation is not crucial, and then maybe or in one way or the other lazy that we don't do it all the time, although we have means to do that.
No, that's absolutely true. And I think even if you don't do certain things, people will understand the intent from the context, for example. So but is intonation the cherry on the cake, or the icing? Or
I'd like to think it's a crucial part of the system.
I agree, but yeah, I don't know.
I don't see questions.
Okay. All right. If there are no questions, then we can.
And so then we will meet with a glass of wine and chat more about intonation.
Oh, yes.
I learned a lot from you and I really enjoyed it. Thank you very much.
You're welcome.
Do you have anything to say to conclude this event?
Yes, I think so. Okay. Well, thank you very much, Gia, and thanks to Berlin for inviting me. Okay.
Bye.